Hello, I picked up this boat in an online auction a while ago. I've been thinking about trying Ardupilot, the boat version of course, for a while, and I was actually thinking about making a boat hull myself, but when this one came up for a pretty good price and in the size that I wanted, I thought I would get it. Originally my plan was to make an airboat, and I wanted to try doing it with two propellers at the back rather than one propeller and a rudder, so that I could use differential thrust. I just thought that would be a little bit easier to set up, and for an airboat I already have most of the parts sitting around already, props and stuff for multi-rotors. It's a little bit bigger than I wanted, but I did want a big one, so this is definitely going to fit the bill for a big one. It's about 1 meter from end to end, about 35-36 centimeters across, and surprisingly heavy. It weighs about 5 kilos at least, possibly even close to 6 kilos, just with nothing in it. In fact, this here probably weighs about 400 grams. For some reason the fiberglass seems to be really heavy. It's like maybe made from actual normal boat, like full-size boat kind of fiberglass. You can see it's really coarse mesh or webbing or whatever you call those grains there. And it looks like it's been made for a petrol engine, I think. It's all very, very chunky and heavy. And originally I was thinking just to get one with just a hull only, without any of this kind of stuff, because that's all I really needed to make an airboat. But since this one has a propeller and a motor shaft and a rudder, albeit a very stiff one, I thought first I might just look into making a normal style boat with it. But when I looked into that, it was going to be fairly expensive, because you kind of have to have a different motor than what I have for my multi-rotors and planes and stuff. And then you're going to need a big beefy servo to turn that rudder, and you're going to need ideally a water-cooled ESC, at least if you want to make it so that it's all sealed up and there's no air in there, so you're not going to be getting air cooling properly. And all that stuff, I don't have it, and it's not cheap either, so I have decided to go back to my airboat idea, and I do have a couple of, I bought some of these motors and props, and it was actually a hexacopter frame that the guy that I bought it off was intending to make a tricopter out of, so I actually have another one of these motors and arms. But as you may have noticed, iForce 2D and tricopters don't really go together, so I'm not going to be making a tricopter out of it, but I have these sitting around, so I thought they're kind of the right size to put on this. So you could put one about there and the other one about there, just as long as the props aren't going to hit each other. And these are 3508 640 kV, I think, and I'm not sure if they actually handle 4S, but at least 3S should be possible. And this is the frame that I got them with, and you can see it's quite a nice frame, this one. It's a Quantum 680 UC, I think is the name of the frame, and it has these little mounting bits there where you slide that piece in there. So I've taken a couple of those off, and I think what I might do is just use those and put them between some bits of aluminium angle on the back here, because this thing's very sturdy, and somehow just sort of mount them on here. And this, I suppose technically it could stay there, but I don't really like it. I'm actually not sure if this boat has ever been run before. I almost said flown. But look at this, it's only held in there by a little bit of that like silicone stuff. There's actually nothing on that side, so it's not too much of a exquisite construction that ripping it out would be much of a loss. So I think I might just rip it out and seal up that hole with a bit of maybe plywood or FR4 and epoxy, and if I stick it on the outside, it will be easy to just grind off later on if I want to sell this and revert it back to this, and I'll just take that off. Shouldn't be too much trouble. So that's my plan at the moment. I have a couple of ESCs. I'm probably going to use some 50 amp ESCs with this, probably doesn't need quite that much, but the other two ESCs that I was planning to use, I kind of messed them up because my plan was to try setting it up as a skid steer control system. So to do that, the motors would need to be able to spin in reverse and forwards. So the way that I had to do that, or that I started to go about doing that, was to take the ESCs and install or flash BL Heli to them, and struck some problems there. Spent about 14 hours in total, and all I managed to do was render one of the ESCs completely damaged, unusable, and I ripped the little solder pads off where you do the flashing of the other ESC, so now I can't even flash that anymore. So I've given up on doing a skid steer, so all I'm going to have is just two normal ESCs doing forward thrust only, which is kind of a bummer, but yeah, the whole BL Heli flashing thing just pissed me off so much I don't think I'm going to bother with it. At least not soldering. See, the problem was the finicky little pads that you have to solder on. It's hard to solder them on there in the first place, and then when they are soldered on there, it's easy for the wire, if you're not careful when you're handling, to pull off. And what happened was one of the wires pulled off, and I didn't notice, and it was just sort of touching on somewhere on the rest of the ESC, and then I powered it up, and the motor sort of twitched a bit, and that was the end of that ESC's life. Yeah, anyway, so that's how things are at the moment. Okay, I have the back of it cleaned up a bit now. This construction here at the bottom, as I found out, was fairly complex, and as it happens, I didn't actually need to undo any of it at all, because this piece at the front here that I thought was welded on, somehow after banging on this to try and get it out and everything, it didn't break off. So I thought, oh, it's pretty strongly stuck on. But when I pulled at it just to confirm, after having done all this and realizing that this fat part here wasn't going to slide through the hole out towards the front, it turns out this was only stuck on by the silicone there, so I didn't need to do any of that at all, so I had to put it all back together. But anyway, I know how it works now. So these bits here, I'm going to change the direction of those. They were facing downwards like that, but they were stuck in with just self-tapping screws into the fairly thin fiberglass, and I didn't really like the thought of that. Now that all the motors that I'm going to stick on there are probably going to be putting a few kilos of thrust forwards that way, I thought it might be better to use some proper nuts and bolts instead. So I took them off, and I'm going to face them upwards to get just a little bit more clearance from the water. And these holes here, I'm going to just put a little bit of FR4 over the top with some epoxy, and then probably silicone sealant on top of that. And these little ones here, I'll just put some bolts in there and silicone over the top of those. Should be right. Okay, so that's what this piece is going to look like. It's just two ugly big chunks of aluminium and some spaces in between, and the original mounts on the end there. So now I just have to get it on the back of there. To mount this piece onto the other part, I'm just using a couple of pieces of angle aluminium in there like that. And this piece here, I beefed this up, so I'm using larger bolts, and they're actual nuts and bolts now, not just the silly self-tapping screws that were in there before. Alright, that's the motor mounts all done and attached. I haven't given too much thought to whether it should be, motors should be facing a little bit up or a little bit down, so I've just sort of tried to make them as vertical or as horizontal thrust, I guess, as possible. See how that goes. It's actually pretty easy to get these on and off, just in case you needed to for transport. I don't think I will, but it's always nice to have that option. So just put the slots in there, and then this one screw will go in to pin it that way, and then another one goes in the front like that on that one, and that's it. So it's quite convenient actually. To mount all the stuff inside, I'm going to use these bits of wood that are just stuck together roughly like that. Some bolts that go through to clamp them together, and in the middle here is going to be this pretty solid metal strip thing with a couple of holes in it. So that's how that ended up. It's nice and secure there. To hold the top on, I'm not really sure how they did it. It looks like there's some holes here that was something to do with that, but there's nothing on the bottom of this. Well, there's that, but I can't really figure out how that was supposed to work. So what I've decided to do is, since I'm not going to be using this hole here, What is this hole here for, by the way? Is it just the air intake for the gas engine, maybe? I have glued a couple of bits of wood together like this, and they fit in there like that, and there's a little groove in the top, and I have a zip tie in one of these wrap straps which is a little bit stretchy, and I'm going to poke the top of that through there and fix it with a little bit of extra wrap strap stuff, and this will be able to poke through, and because it's a little bit stretchy I'm hoping I'll be able to pull it out like this, just enough to get it to go like that, and then hold the top on. And it doesn't really need to hold it on really firmly because most of the work's going to be done by gravity, and the strap just sort of needs to stop it from lifting up when it bounces a bit over a wave or something like that. Speaking of waves, I have stuck these on here, and I'm just about to do a floating test in the bathtub. I ended up just using epoxy for all of this because I realised that I didn't have any silicone anymore. I think I must have thrown it away when I was moving house recently, but this will be fine. That's not so cool. I didn't really want to use epoxy on here. I didn't put it inside the plus thingy there on the screws. It's just around the outside, so hopefully, I don't know if this is going to work, but hopefully if you put a screwdriver in there and twist it, it's just going to go crack and come out. Be not too much damage there, hopefully. But no water is going to get in, that's the main thing. Okay, well the water test seemed to go fine. It didn't actually go down as much as I thought it would in the water. Sort of settled it round about here, the water level I mean. And I put 2 of these 4S 10,000 milliamp hour batteries in there, which is what I'm planning to use, which is 1.6 kilos together, and it only changed the riding height by about 5 millimeters. So it's quite good actually. It means it could take lots and lots more weight, I think. Anyway, so I'm starting to get the electronics stuck in there now. Actually, I think I'm pretty much done. The ESCs are rather unceremoniously just sellotaped onto the back there, and I'll put a little bit of plastic bag over the top, just to protect them from splashes. Not anticipating any overturns or anything like that. And in here we have a sort of a lunchbox thing. GPS is in there. So first off I want to just see how well it picks up the signal from inside there. I'm thinking it may not be too bad actually. Might be usable in there, but if it's not I will of course bring it out to the top here, probably about there. Receiver also in here. Telemetry antenna is inside there as well. So everything's inside here. Not very good positions for radio reception, but won't be going too far afield in the first few trials I think. And then battery's going to go on there, and then that's about it really. And I'm just setting up the Mission Planner stuff at the moment. Now, when I was making all the settings to set this up in Mission Planner, I did of course run into the problem that, as I mentioned at the beginning, the ESCs that I'm using are only made for powering aircraft motors, so they're only going to power it forward. They don't know how to go backwards. And by default, a rover of the type that I'm doing with a sort of a motor on each side would want to use something called skid steering, which looks like the proper name for this is actually differential steering, and it is used on vehicles like tanks and this, and also on these, because the wheels don't steer left or right. They don't have steering wheels, so the 2 wheels on one side will go in one direction, and they can also reverse as well, but they're going in the same direction on each side. So just not so as not to leave anybody behind about what skid steering means. So the way the Mission Planner or the Ardupilot is expecting to run things is expecting to use the kind of ESC that you would use for a car, where the middle position, or 1500 microseconds output PWM, means to stop, and then greater than 1500 means to go forward, and less than 1500 means to go backwards, so that full reverse will be at 1000 microseconds. And the ESCs that I'm using only go stop to forwards on the range from 1000 to 2000. So I had a look around on the forums. I actually thought that this might have possibly been a setting somewhere in Mission Planner where I could change this, because it seems like a fairly simple thing to change. And there were some comments or some forums where people had asked about this in the past a few years ago, and it has not been implemented in Ardupilot itself. So one guy actually took it upon himself to make a little converter with an Arduino, and apparently that worked quite well. And I could have done that, but I
didn't really feel like doing that, and since I had my own build environment ready to try making some changes to the source code myself within Ardupilot code itself, I thought I would try that, and I think I've got it working all right, so I'll just mention a bit about that. So I took my Omnibus F4 Pro off of my little car that I was using it last week, and so far the only changes I've made in Mission Planner are these two things here. I set the frame class to 2 so that it knows that it's a boat now and not a car, and this gives it one more mode. If I understand this correctly, you can now have a loiter mode, because unlike a car, the water currents can actually push a boat away from the point where it wants to be. So loiter will actually sort of turn itself towards that point and head towards it, so that if it gets pushed away it will try and go back. So that's quite a neat thing to be able to do. So you need frame class 2 to be able to do that, and probably some other things as well. Now that it knows that it's a boat, it can do something a little bit more sensibly than if it thinks it's a car. And what did I do here? Yeah, so now that I'm going to be using skid steering, I'll also want to have a mode that's called hold. This actually exists for rovers as well, obviously, because they can do skid steering if you want. And the important point about this is that hold will just never power the motors at all. So it's a little bit like having disarmed, but it's not disarmed. And the reason that you need to do that is that to disarm, as I'll show you at the end of this video, you need to hold the steering fully to the left for 2 seconds to disarm. But if you do that in one of the other modes or in manual mode, that will make the car or the boat turn around and round. So hold just means you can disarm without that happening. It's a little bit safer. So this is the code that I had to change. We'll have a look at that in a minute. And basically, these numbers here, motor left, is one of the values that we were just looking at here, except instead of being in the range from 1000 to 2000, they're in the range from -1 here, 0 in the middle, and then +1 meaning forward. So a little bit different there. But all I needed to do is to say that if the motor output is less than 0, make it 0. So we're just completely ignoring anything in this range here, just squashing everything into here. Well, we're not squashing it in, we're just truncating it and throwing away anything that was negative. And then we multiply it by 2 and subtract 1, so that will squash this range from 0 to 1 into -1 to +1 over there. So hopefully that makes sense. And I also had to change the output that it will give to the motors when it's disarmed, because by default that is something called trim, which is the 1500 microseconds value in the middle here. So this is stop for a skid steer normally, but I wanted stop to be the minimum value for that output, which would in this case would be well, 1000 microseconds or -1. And so anyway, just have a quick look at that. I realized that there's not many people that will be interested in this, but it's in this file called AP Motors Unmanned Ground Vehicle CPP, and it's in output skid steering. So just before you do the final calls to output that throttle value to the motor, this is my little bit of code there that I just showed you. I'd put that in there. And you'll also find that you need to change that to be non-const as well, I think. And then as for what it should do when it's disarmed, that's this bit here, if not armed. Not sure what this disarm disable. I guess there's an option to say that when the vehicle is disarmed, it should just not output any PWM signals at all, which is not really what I want. I want it to output them, so I'll come into this else section and just change that trim value there to say min, like this, for both of those there. And that's what I've done, and as we'll see in a minute, it seems to be working okay, at least for the manual control case. So from what I've seen when I spin these motors up and control it, it's going to do exactly what I want when I'm controlling it myself. But I will just keep in mind when I try this tomorrow that the autopilot does not know that it has no reverse. And I don't think that should really matter, because as far as I know, none of the auto modes try to use reverse, full reverse. It will try to pivot on the spot perhaps, and the pivot motion will be less effective, because instead of being able to make one motor go backwards and one motor go forwards, it's only going to be able to make one motor go forwards, which has the effect of the total thrust means that the boat is going to actually move forwards as well as turn. But I don't think that's going to be a big deal. So what else was I having? So there's a couple of other parameters that I might find myself changing. One of them is pivot turn angle, which means you can set an angle so that if the desired direction of movement is more than this angle away from the current direction of movement, so you want to turn through more than, say, I think 60 degrees is the default. If you want to turn more than 60 degrees, instead of moving forward while turning, it will just stop and turn on the spot. So in that situation, this is when it's going to be trying to do an actual skid steer turn. And if anything's going to give me problems, it might be that sort of behavior when it's trying to do a mission. And turn max G uses the accelerometer when it's turning. This is probably more important for a ground vehicle like a rover. And it just means that you can say if the vehicle feels a certain amount of G-force sideways, to slow down and stop trying to turn so quickly so that it doesn't tip over. But hopefully my boat has enough weight low down in the hull that it's not going to be tipping over, and I'll try not to make it go too fast. So all of the other parameters at this point are exactly the same as I had in my radio-controlled car last week. Hopefully nothing will give me any trouble. By the way, the CG is about here, so it's approximately halfway along the hull. Not really sure where you're supposed to put it, but I'm not expecting it to be giving us a whole lot of speed, so at slow speeds it probably doesn't matter too much where the CG is. It's more important if you're trying to get on plane and actually sort of ride at an efficient angle with the last part of the boat only in the water. I think that's when the CG becomes important, but anyway, we'll see how it goes. Okay, so I finally got everything working how I wanted it to. So we have hold mode here, which does nothing. It's armed, but it doesn't do anything. So that's necessary for a skid steer vehicle, because to disarm, you need to hold the steering fully to the left for 2 seconds like that. Whoops, I don't want to do that because it'll disarm. But anyway, you need that mode to disarm safely. So like that, it should be in manual mode. Alright, so see if I can do this so that you can see both of them. So right, a little bit to the right is going to do that. A little bit to the left is going to do that. And then a little bit forwards is going to do that. And then if I move it to the right a little bit while it's doing that, the one on the left slows down, or it actually stopped. And if I move it a little bit to the left, the other one should slow down. Like that. And it's too heavy to move along here on the grass, so if I do this at full throttle, it's not going to go anywhere, but you may have been able to see it sort of lean forward a slight bit there. So I think it should have enough power, enough thrust to move pretty well on the water. Actually, when it was on its stand on the desk, it actually was able to move a little bit forward, so I was glad that I was actually holding it from the front when I tried that. But obviously the grass is just a bit too... It's not wet enough, I think. If it was wetter and there was more of this turkey shit everywhere, it might be able to slide. But right now it's not going anywhere, so I'll have to take it to the lake tomorrow and see how it goes on water.